Now, this is the data that we have generated from Mukaru. For each factor of environmental conditions, traffic load, material fatigue, and date and time. Now, as we have set stand for environmental conditions as 80, traffic load for 45,000, and material fatigue as 0.8. So, if the values of data exceeded our constant, then it will appear high, as it means that it has high probability of failure, so it has exceed our constant. Now, let's proceed on how we will get the probability of each factor. Now, after we have sorted out the high and low of each factor, then we have to get the number of desired outcomes each factor. First is the environmental conditions. Now, after we get the outcomes, we have to get the total number of entries per month. So these outcomes were sorted out by month. As you can see here, this is ordered months. So in environmental conditions, in 2022 January 1, we have 5 desired outcomes and total number of 8 trials rather. Now, to get the probability, the formula for probability is number of desired outcomes over total number of entries, or we just have to divide both of this data. So we have this result. Now, we just have to repeat this procedure for traffic load and material fatigue. So this is now our overall failure probability. So we have combined the probability, environmental condition, traffic load, and material fatigue. Our formula for this is A2, which represent environmental conditions, B2, which represent traffic load, and C2 which represents material fatigue. So our formula here is A2 plus B2 plus C2 minus A2 times B2 minus A2 times C2 minus B2 times C2 plus A2 times B2 times C2. This formula is for preventing the data to overlap. So this is now the overall failure probability, the results of our formula. Now, Venka will explain to you the conclusion of our overall failure probability.
Well, in conclusion, the overall failure probability as of April 2022 and August 2023 shows the highest risk of failure of 1 and has the lowest in (2022) November and January of 2023.
Now, let's proceed for binomial distribution. Can you tell what is binomial distribution or binomial probability?
Sure. To predict the chances of this failure, we can use something called binomial probability. This is a way to estimate the likelihood of the event happening, like whether or not a bridge might fall or fail under certain conditions.
Okay, thank you, Venkel. Now, let's proceed on how we would calculate the binomial probability of each factor. We just need to calculate the binomial probability. We just need the number of failures per month, and the then the total number of months, which is 24, since it's 2 years, and we also need the probability. Since we have gathered and calculated already the data of each factor, now we can easily compute the binomial probability of each factor. So this is the result for the binomial probability of material fatigue, and this is for traffic load, and this is for environmental conditions. This is the graph for the overall binomial probability, which is being combined by the three factors. Now, then Kyle will explain to you the results of our binomial probability.
Thank you, Hannah, for that. In conclusion, using binomial probability, material fatigue was the most common cause, reaching the highest probability 4 times. Environmental conditions followed, reaching their highest probability twice, which traffic loads reached their highest probability only once.
Thank you, Van Gaal. Now, that is the end of our presentations. Thank you for watching.